To start off our discussion of inverse functions, I want to first refer us to a problem. Sine inverse of -1/2 equals what angle? So we're talking about the inverse functions. We have that little -1. The inverse functions take in the sine value or the ratios and it spits out the angle. So it is the opposite of the original sine function. So what we're looking for is what angle has the sine value of -1/2. When we look at our unit circle, remember that the sine values are all of our y values. When we look at the unit circle, there's actually two places where the sine value is -1/2. And the angles that we might report would be 330 degrees or 210 degrees. Well, what I want you to do, I want you to take out your scientific calculator or whatever calculator that you have, and I want you to make sure that it's in degree mode. And I want you to type in sine inverse of -1/2. And then I want you to hit enter. What answer does your calculator give you? Well, your calculator will give you -30 degrees. So it completely skips this angle altogether, and it gives us 330 degrees, gives us that spot, but it thinks of it as a negative angle. So if you were to start here and then you were to go in the negative direction 30 degrees, it gives us this spot right here where the sine value is -1/2. So the question is why does your calculator not give you 330 or 210, and why does it give you a negative angle? Why does it think about this as a negative angle? That's the question we want to answer in this section of notes. So in order to answer that question, we need to first recall from algebra what is a function. So from college algebra, we talked about what a function is. And remember that for a function, if I put one x value in, I only get one y value out. So there's only one answer for every input. So when I put an x value in, we only get one y value out. And that's a function. Well, not every function has an inverse function. An inverse function, when we talk about inverse functions, we talk about switching around the x and y values. So if I have f inverse, that little -1, the output value becomes the input value, and the input value becomes the output value. So it reverses the ideas of the inputs and outputs. So inverse functions reverse the original functions. Well, in order for a function to have an inverse function, when I switch around the x's and the y values, we still have to have that property that for every input, I only have one output. We only get one answer out. So the idea is that the x and y values will switch places, and we want to compare this to a function that we should be somewhat familiar with, our square function. So here's our square function, and this is actually the function x minus 3 squared. So we're going to take the square function and we shift it to the right 3 units. So we want to look at this picture here. Now, this is not what we would call a one-to-one function. Remember that if it doesn't pass the horizontal line test, we would not call this one-to-one. So this is not a one-to-one function. That means that if I were to take this picture and I was to reverse the ideas of x's and y's, then we would not get a function. So what we have here passes the vertical line test, and I could call it a function. So it passes that vertical line test, so this is a function. But when I look at its inverse, we run into a little bit of a problem. So first of all, the idea of an inverse is that we take the original points, so this would be 3, 0, and the inverse function reverses the order of those points. So instead of 3, 0, the inverse function would take in a 0 and spit out a 3. So it reverses the x and y values of the points themselves. And here we have 4, 1. So in the inverse function that would become 1, 4. But it also has 2, 1. And on the inverse that would become 1, 2. So we can keep going with this idea. This graph has the point 5, 4. So on the inverse that would become 4, 5. But it also has the point 1, 4. So the inverse would be 4, 1. And let's do one more point. That would be 6, 9. So over here we have 9, 6. And 0, 9 would become 9, 0. So the inverse would look like this. Switching around the x and y values, this would be the inverse. The problem is, once I graph the inverse, it fails the vertical line test. That is not a function. So we want to make this have an inverse function. So not just an inverse, but we want the inverse itself to also be a function. So in order to make the inverse a function, I would need to get rid of about half this graph. So starting here, if I get rid of the bottom portion of the graph, then the top portion, so just from here up, would actually pass the vertical line test. So the top part would be a function. So in order for this to have an inverse function, I would have to get rid of a portion of the graph. So let's say we get rid of the left portion of the graph. Now, what we have here on this side would become the inverse function. So if I restrict the original domain, so I limit the x values that are allowed into the function, then when I reverse all of the x and y values, I get something that is also a function. We would call this the inverse function. Well, how do we restrict the domain? Well, when I look at the original parabola, that original square function, if I get rid of the left half of the graph and I only use x values from 3 to positive infinity, then I can actually find an inverse. So that would be the restricted domain. Notice that the range, of course, would be the y values that are used, and the y values start at 0 and then go up from there. So 0 to infinity would be the range. When I look at the inverse function, notice that the y values actually start at 3. So the domain goes from 3, and then the graph goes up from there, so to positive infinity. So the domain and ranges actually switch places because all of the x's for the original function become all of the y's for the inverse function. The whole idea of inverse is that domain and ranges, or x and y values, switch places. The range should become the domain of the inverse. So when I look at the domain, what are the x values? Well, the x values start at 0 and then go toward the right forever. So the y values of the original function become the x values of the inverse function. So the whole idea here is that in order for the original function to actually have what we would call an inverse function, that we have to restrict the original function so that it is 1 to 1. Once I get rid of that left-hand side, then the right-hand side is a 1 to 1 function. Therefore, the inverse will be an inverse function.